Okay, so now I think it is available. Just anyone you just message me on my WhatsApp. I will send this link. I'll just check it is working or not. Okay, so I think it will be recorded. So we will talk about the electrical instruments. Okay, electrical instrument. So in electrical instrument, we have first is your galvanometer, then it's meter bridge, then it's potentiometer. Okay, galvanometer, meter bridge, and potentiometer. So if we talk about galvanometer, so galvanometer we have two types: one side deflection and both side deflection. In one side deflection, like you will have a galvanometer like this way, and this is the current that is coming like this way, and the needle of the galvanometer will point in this direction. And again, you will have the galvanometer here, and this is the circuit, but current is coming from this side. So in this case, your galvanometer will deflect again in the same manner like this way. So just this tells you that some current is passing through it. Okay, it tells you about that some current is passing through the galvanometer. In both side deflection, we have a galvanometer here. Current is coming like this way, and it deflects in this direction. Okay, here this point is 0 point, and here this point is 0 point, and then you will have another one. When the current is changing or reversing its direction, then it is deflected in this direction. It shows that the current is in a reverse order. So this is how your galvanometer works: one side deflection, both side deflection. Okay, in both side deflection, you will get the direction and magnitude of current both together. In one side deflection, you will get only the magnitude of the current that is flowing through the circuit. It will not give you the direction. Okay. Now, what galvanometer have basically? If we talk about the galvanometer, so the symbol of galvanometer that we use is G, and then it is attached with a small resistance that is Rg. Okay, so this is the symbol of galvanometer, where Rg is your resistance of galvanometer. Rg is your resistance of galvanometer. In this also a very important point is that for galvanometer, it's a very it's current sensitive device. Okay, it is current sensitive device. Current sensitive device. Current sensitive device means even a small current will pass through it, it will show some deflection, and it measure currents. It measures a small current. It measures a small current, not large current. A small current whose range goes from milliampere to microampere. range. If large current passes through this galvanometer, then this galvanometer will stop working because the coil will get burned and it will get damaged. So whenever we are using galvanometer, we should understand the condition that high amount of current must not pass through it. If any high amount of current is passing through the galvanometer, then in that case galvanometer will stop working because it will get damaged. So whenever we are using galvanometer, we will make sure that the current passing through the galvanometer is very small. Okay, clear? Now we will see it's working. So we are using galvanometer as a voltmeter and ammeter across the circuit. So with the help of galvanometer, we can make ammeter and voltmeter. So how we can achieve this? How with the help of a galvanometer we can make ammeter or voltmeter? So for that, let's say we want to make ammeter. So first of all, we need to know that how ammeter works. So ammeter it is used to measure current. It is used to measure current, and it is connected in series to the circuit. In series to the circuit. So you will find that we have a circuit where current I is coming and an ammeter is connected like this way. Let's say this is the battery. Like this. So you can see that the ammeter is connected in series to the circuit to measure the current. Ammeter generally have very less resistance. Ammeter has very small resistance, or you can say negligible resistance. Okay, and for ideal ammeter, I will say that ideal ammeter has zero resistance. Why it is like this way? Because suppose if the ammeter is there and if it has zero resistance, then the actual current which is passing through this path can be determined. But if the ammeter will have some resistance, so overall the current in the circuit will change, because right now the total resistance is R plus R. And if I consider the resistance of ammeter, then the resistance will increase and I will decrease. So it will not detect the exact current, it will detect the current value which is slightly lesser than I. That's why we say that ideal ammeter must have zero resistance so that it will measure the exact value of current passing through this path. So to understand it, I'm giving you one question which you will do. Suppose this is the circuit, this is let's say 10 volt, and its internal resistance I'm saying it as a 1 ohm, and then there is another resistance, let's say, and this is 9 ohm. Now when I connected an ammeter here and I'm saying that ammeter is ideal. So let's say I connected an ammeter here and I'm saying that this ammeter is ideal ammeter. So in that case, if I measure the current value, then current value will be how much? So I will write I equals to total potential by total resistance 9 plus 1. That is 1. But in case of non-ideal ammeter, in case of non-ideal ammeter, we will have here 9 ohm resistance, and let's say this is internal resistance is 1 ohm. Then the battery that is of 10 volt, and there is an ammeter which is non-ideal, and it is shown that 2 ohm is there. 2 ohm means it is the resistance of ammeter. Now they're asking us to calculate the current flowing in the circuit. So to calculate the current flowing in the circuit, let's say the current is I. So I will be saying that I dash, let's say. So I dash will be how much? That is 10 by total resistance 9 plus 1 plus 2. So that is 10 by 12, and so this is I equals to 5 by 6. And 5 by 6 is basically 6 at the 48, and then we will have 2, 6 3 the 18, and like this one. So current value is 8.33 ampere, which is lesser than the current value is 8.33 ampere, which is lesser than the actual current that has to be measured using ammeter. So ammeter, ideal ammeter has zero resistance and non-ideal ammeter has resistance, and because of that we can see that the current value has dropped, current value has decreased. That's why it is necessary that when we are going to make an ammeter, we must make sure that its resistance is either zero, which is practically not possible. So we will consider its resistance, or we will make the ammeter in such a way that its resistance must be smaller. Okay, this is clear, everybody. Again, say what you are saying. 0.833, no, no, it will be 8 point. Oh, sorry, yes, 0.833. Sorry, sorry. 0.833. Okay, now just do one question I'm giving. This is a battery that is 15 volt, resistance is 2 ohm, 5 ohm resistor. There is an ammeter, and its resistance is 8 ohm. So first variant is ideal, second variant is non-ideal. 8 ohm for the ammeter. So did you get the answer? Yes, what's the answer? Yes, for ideal one, I through the ammeter is 15 by 7. Yes, that is right. And for non-ideal, 1 ampere. 15 by 5 plus 8 plus 2. Okay, understood. Now we will see the conversion of galvanometer into ammeter. Means how with the help of galvanometer we can make ammeter. So basically, we have a galvanometer, and it is to be connected across a circuit in which the current I is flowing. Let's say. Now, if I directly connect this galvanometer across the circuit, what will happen? The galvanometer will get damaged because of high amount of current passing through it. Yes or no? High amount of current is passing through it, so because of that, the galvanometer coil will get worn. It will get damaged. So we cannot connect the galvanometer in series to the circuit like this way. Yes, there is the risk of uh, damaging of these devices. So what to do? So for that, what I will do, I will connect a shunt resistor here in parallel to this one, and the shunt resistor value must be much smaller than the galvanometer resistance. So because of that, most of the current will pass through the shunt resistor, and current through the galvanometer will be Ig only, which is under its rated value, and remaining current will pass through I minus Ig through the shunt resistor. So when a small current is passing through the galvanometer coil, then in that case galvanometer coil will not get damaged, and now we can use it like this as an ammeter. Now the question is, sir, but ammeter, this galvanometer will read Ig current, it will not read I current, yes or no? And we are using it as an ammeter, that means it must read I current. So how we can determine that value of I? So the explanation is very easy. With the help of a multiplier, no, corresponding to each division, we will consider that. Let's say for 1 milliampere, I am saying that the current is main current is equivalent to 1 ampere, like this way. Okay, so with the help of a multiplier that will be given, we can detect the actual current passing through this galvanometer. Understood? Yes. So to convert galvanometer into ammeter, a shunt resistor Rs much lesser than Rg must be connected in parallel to the galvanometer. Then this entire setup will behave like ammeter. Now the question is that why the resistance of shunt resistance must be smaller than the galvanometer resistance. The explanation for this one is very simple. We can say that as galvanometer coil measures a small current only, and in case of large current, it gets damaged. So when a shunt resistor is connected parallel, when a shunt resistance is connected parallel, most of the current passes through the shunt resistor, and small current Ig passes through galvanometer, and by this way galvanometer will work normally. Understood? So this is our galvanometer coil that has Rg, and here this is shunt resistor. Current I is coming using Kirchhoff's law. Ig will pass through it. I minus Ig will pass through it. I will say that the potential of point A and B will be same. BAB, I will be writing it as Ig into Rg, and this must be equals to I minus Ig into Rs. So R shunt I will be getting here as Ig into Rg by I minus Ig. If Ig is much smaller than I, then R shunt will be written as Ig Rg by simply I. Okay? Now, Try to solve this problem. Got the answer? Did you get the answer? Okay. So what is the value of sun which passes 10% of the main current through the galvanometer of 99 ohm? So we have a galvanometer and Rg is 99 ohm, and it says that 10% of the main current passes through the galvanometer. So this is our sun resistor. So suppose here I is coming, 100 ampere is coming. So it's 10% that is coming here, 10 ampere, and 19 ampere is going to this RS. So I will write 90 times RS should be equals to 10 times 99. So RS is equals to 990 by 90. So RS will be 11 ohm. Understood? Try to solve this question, then we'll see well. What the answer? What's your answer? Yes, I1 is 5 ampere. Very good. What is I2? So percentage change, percentage error, delta I by I into 100%. Yes or no? So this will be 5 minus 4 by 5 into 100%. That is 20% of change is there in the current. Current has dropped by 20%. Yes? So this is how your ammeter works. Now we'll see voltmeter. Hmm. So basically, how voltmeter works. So in voltmeter, it is used to measure potential difference. It is used to measure potential difference across the 2 points of the circuit. It is connected in parallel to the point where potential difference is to be determined. The potential difference is to be determined. Ideal voltmeter has infinite resistance. Now suppose this is the resistor across which we have to measure the potential difference. 10 ohm. Current is flowing, battery is of 10 volt, let's say, and 20 volt, let's say, and this is 20 volt and this is 5 ohm or 4 ohm. Its internal resistance, I'm saying it as a 1. Now I have to measure the potential difference across this resistor. So I will connect a voltmeter in parallel to it like this way. And now because the voltmeter has infinite resistance, so because of that no current will pass through this branch. All the current will pass through it. And if I ask you the value of I will be 20 by 5, that is 4 ampere. So V across 4M, if I write, I will be writing I into 4, that is 16 volt. So reading of voltmeter is how much? 16. So this is a case for ideal voltmeter. This is a case for ideal voltmeter. Now here I am giving one question related to non-ideal voltmeter. So let's say same question. This is 20 volt. This is 1 ohm. This resistance is 4 ohm. And then I connected a voltmeter here, whose resistance is 12 ohm. 12 ohm. Now I'm asking you find the reading of voltmeter. Find the reading of voltmeter. Did you get the answer? Tell me, did you get the answer, Nivan? Voltage. Okay. Now here you will find that first of all we will calculate the current here. So if I draw the equivalent circuit, Then this is 20 volt. This is 1 ohm. This is 4 ohm here, and this is 12 ohm. Yes or no? And then this one. So 12 and 4, if I calculate 12 into 4 by 12 plus 4, then you will get here 3. 48 by 16, that is 3 here. So the current passing through the battery will be, this is 20 volt, and this is 1 ohm, and this is 3 ohm. If I calculate the current here, then I will be how much here? 20 by 4, that is 5 ampere. So 5 ampere current is coming in, and so equivalent potential difference. So here you can see basically across it the voltmeter is connected. So voltage of voltmeter B reading will be how much? So this is 5 into 3 ohm, and that is how much? 15 volt. Is that clear? Or from here also you can say that 5 is there. So I will divide the 5 in 4 3, that means 4 ratios, in which 12 for 16. Okay. 4 3 are 12. So 1 is to 3 ratio we have here. So 4 ratio. So 5 by 4. So out of that 12 and 4. So you can say the current through this one is I1, the current through this two is I2, and you can write 12 I2 equals to 4 I1 because voltage will be same. So I1 is equals to 3 times I2, and I we know that is I1 plus I2. I is basically 5 ampere, and I1 is 3 times I2 plus I2. So I2 is basically 5 by 4, and I1 is basically 15 by 4. And if you calculate the voltage here using this result, then you will be getting 15 by 4 here. 15 by 4 into 4, that will give you 15 volt. Or you can write here uh, I2, that is 5 by 4 into 12, that will also give you same as 12. Okay, this is clear. Now how we can make voltmeter from the galvanometer? Conversion of galvanometer into voltmeter. So in this situation, this is the galvanometer, and we have to use it as a voltmeter. So again, we cannot directly connect in parallel to the resistance. Like suppose this is the resistance across which the potential is to be determined. This is the battery. So if we connect it like this way, then because the galvanometer has a very small resistance, all current will pass through it, and again this voltmeter will get damaged. So we cannot connect it like this way. There is some modification that must be done without before adding this galvanometer across this resistor. So what is that? Let's see here. So to make it working like a voltmeter, it must have the property of voltmeter. Like it must have very high resistance. And for that only we will connect a shunt resistor of very high resistance across it. R shunt must be much greater than RG. Now because the resistance is too much higher, so current flowing through this will be negligible. And now the voltage that has to be measured is V. Okay, and current passing through the galvanometer must be Ig only. So I will be writing IgRg plus IgRs. This should be a voltage reading that we have to measure. So you will get Rg plus Rs, that is equals to V by Ig, and from here Rs you will be getting V by Ig minus of Rg. So this is how we can determine the resistance of the shunt resistance for the galvanometer to convert into voltmeter. So point that need to be remembered is a shunt resistor of very high value, that is R shunt much greater than Rg, must be connected in series to the must be connected in series to the galvanometer, and then entire setup must be connected in parallel across the resistor about which potential difference is to be determined. Okay, this is clear, student. Tell me this is clear, student. Everybody, this is clear. So we'll practice one question to understand this concept. Solve it. See you are capable of doing it or not. Then I will solve it. Okay, so here a galvanometer has a resistance G ohm. So the galvanometer has a resistance of G ohm, and its range is V volt. So basically, it measures the potential difference of V volt. So I will write Ig into Rg is how much, that is V volt. Calculate the resistance to be used in series with it to extend its range to NV. So how much of resistance I will connect across in series to this one, so that its range becomes NV. So I will write Ig into Rg plus Rs, that must be equals to NV. And I will write Ig Rg plus Rs, NV we know that is Ig Rg. You can see Ig and Rg will cancel, so I will write Rg plus Rs by Rg, that is N. So Rs by Rg, that is your N minus 1. So Rs is basically N minus 1 times Rg. And Rg is nothing but Rg is given as G. So I will write shunt resistor as N minus 1 times. Okay, this is clear. Solve this problem. Solve it. Got the answer? In the first one, it's easy enough. Find the potential difference across resistance 300 ohm. So you can calculate the current here, and I will be how much? So 300 and 200, 500. So 100 by 500. And so V across 300 will be how much? So 300 times I. So 300 into 100 by 500. That is 300 by 5, and that is 60 volt. But for this case, the circuit, if you draw, this is 100 volt, this is 200, and this 300 and 600 will become 200 again. So V across 200, if you calculate V across it, voltage, then voltage will be how much? Because both are equal resistance, so 50% drop will be here, 50% drop will be here. So V across 200 will be 50. You got this, everyone? 600 and 300 will become 200, yes or no? Because they are in parallel. Now this is 200 and 200 are in series. So both are equal resistance. So I can say 50% drop will be here and 50% drop will be here directly. Yes or no? Or you can find current. Current you will be writing 100 by total resistance 400, and potential across this terminal will be how much into 200. You can see this is 50 volt. All right. 600 and 300 are in parallel. If you calculate R parallel, R equivalent, then R equivalent will be how much? 600 into 300 by 600 plus 300. Yes or no? For two resistance in parallel, R equivalent we write R1 R2 by R1 plus R2. Yes. So if we simplify, it will become 200. Okay. Okay then. This much for today. And if you want the link for recorded session, you will message me. I will send you the link. Okay. Okay. Thank you.